Thank you very much. My name's K.L. Kaindek with Mocana, and how many of you are concerned about IoT security? How many of you have no idea how you will actually scale to support the billions of devices that need to be secured? Well, today we're going to talk about that. I'm super excited about what we're doing with Intel in this area. And what we're going to talk about is securing the life cycle of security for devices. So it's no secret, right? We've had a series of cyber attacks, and really it's becoming more like cyber warfare. Gartner estimates that about half of devices are going to be vulnerable through this year. Mocana thinks it's more like 98%. I mean, let's just look at the ridiculous hacks that happen on a day-to-day basis. From surveillance cameras to industrial control devices to now our electrical grid. So what's going on? Well, when you look at the challenge of securing devices, you can see what's happening, right? The hackers are actually able to get around many of the common IT defenses to compromise IoT devices and ICS, or industrial control devices. Principally because many of these devices have very weak security. I think you would all agree that some of the devices that you purchase for your home, or even that you may have in your office that are legacy, lack things that you would expect on your own computer or your smartphone, right? They lack a way to secure keys. They lack a secure boot process to make sure no one can interrupt the boot process. And they lack some basic set of crypto or authentication on the device. Taken all together, it makes these devices actually pretty easy to compromise. So a lot of the security vulnerabilities don't have to do with a published security vulnerability that you might read about in the newspaper. They actually have to do with IoT and industrial control devices lacking essential security to begin with. And this is what Intel and Mocana are solving. And we're going to solve it across the supply chain. For any of you involved in manufacturing a device or using devices that are in your own, either in your enterprise or within your own manufacturing process, sometimes you have to wonder, how is that device actually secured? And could a hacker have come in during that manufacturing process and compromised it? You know, how is this all happening? And that has to do with compromising the manufacturing supply chain. And it starts all the way from the silicon going into the device. Let me explain. So when developing an IoT device, you may take this device and it starts with developing software that can be put on a chip, right? It may have a CPU, it may be a SoC, it may be something that's going onto a board. It's going to have RAM and ROM built into it, right? That is what you're going to be developing your application on, not a full-blown server. To do that, you have to do some hardware integration. You have to think about crypto and cyber for the device. You may be incorporating late next generation technologies like Intel, EPID, and TPM. You have to think about compliance and application integration. Yeah. During that process, you have to have a way that's easy to secure the device. Once the device has the application on the chip, you need to put that and manufacture it into the device. And you run into other issues, such as, well, how do you ensure that that device has a secure identity, a secure credential? That's called enrollment and onboarding. How do you scale that to support potentially millions of units, right? Imagine smart meters or cars. How do you scale to that level? Also supply chain challenges. When you ship the device, how do you ensure that someone hasn't interrupted the shipment or come into your storeroom to physically compromise the device and compromise it so that they have access to some of the keys you may have stored on it? All of these are very real scenarios, and they happen more often than you think. Once it gets to the customer, and the customer is using your device, they have to activate it. If you receive something at home, how do you activate the device? If you have a set-top box from your cable television provider, they all go through a device activation process once it gets to your home. How do you ensure that that's secure? And then ongoing, how do you ensure that down the line, any update of firmware or software or data configuration files aren't actually compromised. It's a complicated process, and that's why Intel and Mocana have gotten together to solve the problem.
The good news is a lot of the breaches that we see and a lot of the issues around IoT security aren't anything terrifying. We have solutions that really handle a lot of the breaches that we're seeing in the market. It's just a matter of implementing them. And what Intel and Mocana are here to do is make it easy for you to implement security starting with the minute that device turns on. So what Intel has done is we have a solution called Secure Device Onboard. And it starts with a hardware root of trust. And it allows devices to be taken out of the box and powered on, securely authenticated bidirectionally. So Mocana's platform can authenticate that it owns the device. The device can authenticate that it's the device you purchased. And then we create a secure tunnel for which you can provision the device to the Mocana system and other ISV-supported systems automatically. So we're removing human error, and things like the Mariah botnet, where the default passwords weren't changed, can be things of the past because you're programmatically allowing the devices to be securely onboarded. So the minute that they hit your corporate network, they're authenticated, they're secured, they have the right software image on them, they have the right update, and the installer doesn't need to be anyone that you trust, it doesn't need to be anyone that could potentially make human error and leave your network at risk. So Intel and Mocana are allowing you to rest easy at night because you're starting with a secure onboard, and then Mocana takes over for the lifecycle management of the solution.
We recently announced Mocana TrustCenter, and Mocana TrustCenter allows you to take that onboarding process and actually go to all of the next steps to really enroll that device, implement a digital certificate, and then update it securely. So let me explain how it works. First of all, on the device, you have Mocana TrustPoint, which is a software for endpoint security for IoT. It's been around, it's on about 100 million devices used broadly across the industry. And you also have an update client and an enrollment client from Mocana. The application is also on that device. TrustCenter runs on a server platform, either on bare metal or a private and public cloud. It has a dashboard that can be accessed via a web client that you can use to manage enrollment and update of that device. And then it can sit on any database that you choose, hierarchical database. If you have your own device management platform or orchestration platform, you can simply integrate that to our services connector. Now, TrustCenter is also connected to a back-end CA. So we can take the information, for example, from Intel SDO, validating the identity of that device, connect it to our enrollment service, and automatically install a digital certificate. You could be running Microsoft CA, DigiCert, any other third-party CA, and we're automating this whole process to seconds. This is a really big deal in IoT because it can take minutes, up to 20 minutes for some manual processes to fully implement an ID and enroll a device with a digital certificate. So now you get to a point where, wow, okay, we can scale this to billions and to do it securely. TrustPoint, I talked a bit about that. It's a set of cybersecurity controls that can integrate with your application that can protect the device. Again, it's protecting about 100 million devices today from a variety of the largest industrial and IoT companies. And it already integrates with several chipsets and RTOSes, because typically on a board you're going to have more than just one chipset, and you may have to deal with multiple real-time operating systems, especially if you're a large manufacturer. TrustCenter, a couple of big things about it. Really, one, it's about zero-touch enrollment. This is about automation. It's about having tools for multiple companies within the supply chain. It's about speed, it's about scalability, and it's about automation. And that is the key to securing IoT. Without those things, we're going to again be in this situation where the devices that we think should be secured aren't, because it's just too difficult for the manufacturers. So let me show you how cool this is. Okay, let's say you have a device, a robot, right, in a factory, and you've shipped it to your customer. And on that device, you have an Intel SDO client. And it also has an Intel EPID ID built into the chip. That device, through the Intel SDO client, connects to Intel SDO, Secure Device Onboard. That then connects back to the customer running Mocana TrustCenter, and also they can communicate directly with Intel SDO. It's at this point that the customer confirms back to SDO that that device is valid. And then it communicates that to TrustCenter, and TrustCenter updates its database. At that point, SDO returns information to the SDO client, as well as two binaries, the enrollment client and the update client of Mocana's. So in that confirmation, it returns those two binaries. At that point, more magic happens. So that device can now communicate back to the enrollment service, back to a CA, provision a certificate, and once it has a certificate, it can do things like it has a secure digital identity. It can begin to communicate securely using a digital, like an X509 cert. And once it's connected to this system, it can begin to use the update client, which is being able to handle its first update, which could be actually the application integrated with Mocana TrustPoint. So what that means is you can actually begin to ship devices without all of your intellectual property on the device, with nothing more than a secure Intel EPID ID, Intel SDO, and once it gets to the customer, it can go through an onboarding and enrollment process that allows you to install your software when you know that that device is safely in the hands and the location and the owner where you feel comfortable doing that. Complete control, and all of this enrollment process again happens in seconds. And incredible automation from the perspective of IoT.
Yeah, and we should add that even though it is an Intel service, we also provide onboarding for non-Intel silicon. So we have partnerships with Microchip, Atmel, Infineon, Cypress Semiconductor, which allows you to onboard non-Intel devices into the Mocana system using the same Intel Secure Device Onboard service.
Absolutely. And then with Mocana TrustPoint on the endpoint, with the device securely enrolled, we handle things like secure boot, remote attestation, authentication, secure transport, crypto, and we ensure that the device is trustworthy. This is probably one of the most important things that's overlooked in IoT today. How can you trust the data if you can't trust the device? We're building all of our analytics around devices that actually aren't very trustworthy. And this is a problem, and it's going to come back to us unless we fix it. And again, this connects back to the update database, all integrates to TrustCenter, and allows you to have control. So let me show you another aspect of this that gets right to the heart of securing the supply chain. And that is ensuring that a software supplier that wants to implement or is recommending an update for a device, like an ECU on a car, can ensure that their software has not been tampered with and is installed on a device that is authenticated by the manufacturer. So here's how it goes. The software supplier has TrustCenter running on their platform. They take their software update, package it with TrustCenter, and pass it on to the ECU manufacturer. An ECU is an electronic control unit. It does things like handle autonomous driving in cars, infotainment, safety, all those sorts of things in cars. The manufacturer takes that update, decrypts it, tests it on their system. Once they think it's okay, they can take that update, sign it, untampered with, and provide it to the auto manufacturer, to a Ford, a Toyota, a GM. They do the same thing, sign it, pass it on to the systems integrator managing their network, or the dealership that's installing the device. These guys are actually the publishers of the update to those ECUs. They can do that securely over a LoRa network, over an Ethernet network within a dealership, and then the the ECU has enough security intelligence on it to be able to use multi-factor verification to verify that all of the companies within the supply chain have signed it, and that the certificates are valid and the update is valid. Now think about that in the context of 100 million cars on the road, each with 100 ECUs in them, driving through cities with millions of sensors, smart meters, lights, traffic systems, things that are looking at traffic, that are looking at everything for traffic and transportation safety, right? Going back to the home. All of these vehicle-to-vehicle or V2X communications need to be secured. And it's hard to think about how we're going to do that without automation and security and reliability.